Hi, this is Mrs. Wiederhold, and welcome to my lesson video on graphs of quadratic functions. Now let's get started. First, I want to give you a chance to plot this graph of the parent quadratic function. The vertex is at 0, 0, and then remember, the parent function is y equals x squared, so you could say if x is 1, 1 squared is 1. If x is negative 1, negative 1 squared is 1. And then you do the same with 2. If x is 2, 2 squared is 4. If x is negative 2, negative 2 squared is also 4. And we do the same for the 3. 3 squared is 9, and negative 3 squared is 9. If you have your graphing calculator, you can always put it into y equals and then go to the table and make sure you get your x's and y's correct. First, let's review the vertex form of a quadratic function. It is y equals a times x minus h squared plus k, where h and k are your vertex. Now let's look at the standard form of this equation. It would be y equals ax squared plus bx plus c. Now, the a is the coefficient of x squared, and sometimes that's referred to as the coefficient of the quadratic term. B is the coefficient of x, which is sometimes referred to as the coefficient of the linear term. And then c is the constant. The x-intercept is where your graph crosses or touches the x-axis. The y-intercept is where your graph crosses or touches the y-axis. In this graph, our x-intercept is 0 because it is touching the x-axis where x equals 0. And then our y-intercept is also 0. This graph crosses the y-axis where y equals 0. Hopefully you all remember the domain for a quadratic parent function, and that domain is from negative infinity to positive infinity. And remember, no matter how we translate this graph, whether we shift it left, right, or up, down, the domain will never change. The range for this function is from 0 to infinity. Now, remember, you use a bracket because the graph, it does equal 0, the lowest point of the graph. Now with range, if we shift this up, then yes, the 0, the first number in our range, will change. If we shift the graph up, it will be a positive number. If we shift the graph down, that 0 will turn into a negative number. Now let's continue looking at some more characteristics of the quadratic function. The axis of symmetry is represented by its initials, AOS. And what that is a vertical line that cuts your graph in half. Okay? Now I know my parabola, this is called a parabola, I know mine's not a very good representation of one, but the left side is supposed to be exactly the same as the right side. Now even though I don't have a pretty parabola, if you look at my points, they are mirror images of each other across the y-axis. Okay? Now axis of symmetry is written as an equation. It would be x equals, and it equals wherever it crosses the x-axis. And in this case, it crosses at 0. Now if your equation is in standard form and you don't have a graph to look at, you can also find the axis of symmetry by taking the negative of the b value, the b coefficient, dividing it by 2 times a. And a is the coefficient of the x squared term. Now when finding the vertex, there are actually 3 ways to do this. The first way is graphically. If you look at your graph, you can visually see the vertex. And in this parabola, that is the lowest point because it opens upward. And our vertex is 0, 0. Now when your equation is in standard form, you can use the equation, or excuse me, use the formula for the axis of symmetry to find the x coordinate. And so what you would do is that would look like this. You would take the negative of b divided by 2a. Now that's the x coordinate of your vertex. You would then plug that into your standard form equation. You would plug that in for the x value, and your answer would be the y value. So how that looks as a formula here, it would be the f of negative b divided by 2a. Now, I know this might look a little confusing, and we can discuss this more in class. If your equation is in vertex form, well, remember, the h value and the k value are your vertex. Okay, so your h value and your k value are your vertex. And when your quadratic function is in parent form, the x or the h value is 0 and the k value is 0. The last characteristic we want to look at is your parabola, or is your quadratic function, does it have a minimum or a maximum? And what that means is your vertex at a minimum point, the lowest point of your parabola, or is your vertex at a maximum or the highest point in your parabola? A lot of times the minimum is represented by the first three letters, MIN, and the maximum will be represented by the first three letters, MAX. So now let's do an example together. In this example, we're going to use the equation y equals negative 2x squared minus 4x plus 6. At this time, go ahead and pause this lesson so that you can plot the graph that you see. And you can look at my points and just plot those points. We have the vertex is up at negative 1, 8. And then on the left, I have a point that is negative 2, 6. On the right, I have one that is 0, 6. And then going down on the left, I have one that is negative 2, 0. And just to the right of that, it's 1, 0. And then down at the bottom left, negative 4, 10. Negative 4, negative 10. And then I have negative 4, negative 10. Now that you've drawn your graph, let's go up and let's start identifying our coefficients. The first one, the letter A, well, that coefficient is negative 2. Now remember, what does the negative sign mean? It means that our graph is flipped upside down, and if you look, ours is. Instead of opening upward, it opens downward. The 2, remember, means that it is going to be narrower. It is a vertical stretch. Now let's look at B. That one is going to be negative 4. And do you see what I'm doing? I'm taking the sign with the number. The sign in front of the number or in front of the coefficient goes with it. And then my C value is 6. Now let's identify the y-intercept. Now looking at the graph, you can easily see where it is because it is where your graph crosses the y-axis. But when you're looking at the standard equation or the standard form of your equation, your y-intercept is going to be your C value. More specifically, it's going to be the y-coordinate of your the y-coordinate of your y-intercept. So let me show you in writing. Okay, so the C value is the y-coordinate of your y-intercept. And remember, a y-intercept, sometimes we just say the y-intercept is 6. But it really, you need to remember that it represents an ordered pair, 0, 6. Now let's find our x-intercepts. Now there is a way to do this algebraically, and we will be learning that later. First, we're going to learn how to do it by looking at the graph. Now remember, x-intercepts are where the graph crosses or touches the x-axis. And in this example, I have two places that it is crossing the x-axis. The first place is where x is negative 2. So you would write that as an ordered pair, negative 2, 0. Because you went over to the left 2 and you did not go up or down, so that's negative 2, 0. The other ordered pair that represents my other x-intercept would be positive 1, 0. Now let's look at the x-axis, the axis of symmetry. Now remember, the axis of symmetry is what cuts our graph in half vertically. And so it is always going to go through the vertex, and so the axis of symmetry is the x-coordinate of that vertex. We always have to write it as an equation though. So what is the x-coordinate of our vertex? Well, our vertex is negative 1, 8. So x equals negative 1. That is where this would cross the x-axis, where x is negative 1. Now I've just stated our vertex. I went and I looked at the graph. It's up here, and I know the x-coordinate's negative 1, and the y-coordinate is 8. So that's going to be very easy for us to find. Negative 1, positive 8. Now before we look at the domain and range, I want us to identify, go down to where you see max or min, and I want to identify, does this parabola have a maximum, meaning is its vertex at the top, the highest point, or does this parabola have a minimum where its vertex would be at the lowest point? And I think it's very easy to see that it is the maximum. That means that this parabola is opening downward and the highest point is the vertex. Finally, let's do our domain and range. Now remember, the domain, no matter what you do to this graph, the domain will always be from negative infinity to positive infinity, because it is forever going towards the left, forever going towards the right. Now the range is going to look different than the parent function. Remember, the parent function, the range was from 0 to infinity. But if you look at our graph, it's not starting at 0, or it's not starting at a specific point anywhere and going up towards infinity. It's actually starting down here from negative infinity, and it only goes as high as the y-coordinate of our vertex. So you would write the range like this: from negative infinity, and what is the y-coordinate of our vertex? It's positive 8, so it only goes up to 8. Now please remember, you can always go back through this video again. Please stop it, pause it, whatever you need to do to help you to understand this material. But always know that in class we can discuss it then. You can always ask me questions. Star or put a circle around anything you have a question about, so that in case you forget it between now and the time you see me, it will be a reminder of what you need to ask. I hope this video has helped you, and I do look forward to working with you again. Bye-bye.